Okay, good evening all. We'll start with our class session. Um, See, before going to this chapter, we have to go through the biotechnology, that is principles of biotechnology. I know that result has been announced, all are passed. It's a happy news to you all. Okay, but this is a time to prepare to ourselves. We have to prepare to ourselves. Okay, so try to read as much as possible. Try to read as much as possible. And as I told you, okay. Now, as I told you to go through the chapters of principles of biotechnology. I don't know how many of you have gone through those chapters, but without knowing that chapter, this chapter will be very difficult because the principles of biotechnology, where we study about how a basic tools are used to construct a recombinant DNA technology tools used to construct the okay user to construct the basic tools. Okay, say like enzymes like restriction endonuclease, it may be a ligases or it may be a RNA polymerase, or it can be an so many methods we can the DNA polymerase 1, DNA polymerase 2. Okay, we use these things as a tool, and we use these tool to manufacture the some of the genetically engineered items. Okay, here in the principles we are purely dealing with the uh, okay, in the principles we are here purely we are purely dealing with the how the genetic, that is a product, are dealt with or products are made using our tools. To study the application, we need some of the principles. We need some of the principles. Okay, coming to the last chapters of principles of biotechnology. Okay, see, I will do one thing after every 2 to 3 slides. Unmute you all, and if you have any clarification, you can ask me. Okay, because it will be interrupting for this session. Okay, Coming to the application of biotechnology, in the application of biotechnology, we need a few basics of biotechnology and its tools from our previous chapter. So I told you to go through it. I don't know how many of you have gone through it. Okay. Anyway, here coming to the applications of biotechnology. In the applications of biotechnology, we deals with its only the application, how the products are made. Okay, as biotechnology says, the genetically engineered things which gives a desirable product, which gives a desirable product. From those desirable products, we can generate large number of our products. Okay, using microorganisms. Okay, and the genetically engineering is done to those microorganisms. Coming to applications of biotechnology, it includes therapeutic use. Therapeutic, as the therapeutic, that is therapeutic use, we can see in the field of medicine. It is used in the field of medicine. Diagnostic, to identify the diseases, the rare genetic diseases in the therapeutic, and we can use um, we use for the cure of some of the rare genetic diseases. Okay, and genetically modified crops for to build a large amount of crops with high protein value in these small places. Okay, and food processing industries, that it may be in the manufacturing cheese, or it may be in the manufacture of wines, or some other food processing industries. Okay, and bioremediation and waste treatment, here we use the biotechnology. What are the three areas of biotechnology? As I told you, we use the tools in the biotechnology. Here tools are the enzymes. Here tools are the enzymes. We use these tools to access the enzymes. Okay, what are the tools comes we can say here, the enzymes. The most of the tools are enzymes. Okay, it may be and it may enzymes includes the restriction endonuclease ligases and the polymerases, and so many enzymes. There are so many enzymes. Okay, what are the the critical areas of biotechnology? That is providing best catalyst. It may be the microbes or enzymes. What is a catalyst? A catalyst which induces the reaction and makes the reaction fast. Okay, to make the reaction fast, we need the some of the microorganisms, or it may be enzymes, or the enzymes from some of the microorganisms we can use to provide the as a best catalyst and to speed up the reaction, and creating the optimal condition through genetic engineering for a catalyst. Or that means we can design our own catalyst through the genetic engineering. Okay, and downstream processing technology to purify the protein and organic compounds. What is downstream? That is, we have a microorganism, we have put the microorganisms in the bioreactor, and it has done its processing. Once in the bioreactor, those actions which gives it may be a protein or the outcome of the product has to be purified. The purification is done by the downstream process technology. Okay, coming to what are the applications of biotechnology? As this chapter we deal with very few applications. There are numerous applications of biotechnology, but we deal here with a very few. Very few means very few. Okay, that is in the field of agriculture. Okay, in the coming to agriculture, there are three classifications. One is agrochemical basis. What is agrochemical basis? Use of the chemicals, that is purely it may be a potassium nitrate, sodium, some of the chemicals we use in the field in our routine fields in the agriculture. Okay, or it may be organic agriculture, or it can be a organic agriculture, or genetic engineered crop. But we don't go through the agrochemical basis or the organic agriculture. We only go through the genetically engineered crop base. We only go through the genetically engineered crop based method. Okay, that is the how the what we call how we use the biotechnological tools to improve our crops to overcome some of the effects. Okay, coming to the green revolution. Coming to the green revolution, we have The efforts have, that is, there are numerous efforts. Okay, here we can okay, here the Dr. M.S. Swaminathan, as you know, who is a father of Green Revolution in India. Okay, his Green Revolution was the main aim, that is, India having a many numerous or huge population, and there are only few fields to grow the crops and to feed the numerous population. So there was a need to introduce a new method of agriculture, the new techniques to the agriculture, so that in short period of time, they have, in the short period of time, they have to get the large number of the outcomes, that is a byproduct, which can feed the numerous in that is peoples or the large population. It was a main goal of Dr. M.S. Swaminathan, and he used the radiation technology and the genetic engineering technology to build a crop which can grow fast and which can overcome so many the difficulties which are present in the fields, and it can be grown in short period. That is, his concept was from land to field. His concept was from land to field. Okay, this was about the green revolution by Dr. M.S. Swaminathan. Okay, but coming to our that is application in the field of biotechnology, we use the genetically modified organism. What are genetically modified organisms? The organisms whose the genes have been altered to get a desired product what we need. Okay, the normal genes are altered to get a desired product. Where we alter the genes in the plants, bacteria, fungi, and animals, which are introduced, which are altered, manipulated, and introduced in the host to get a desired product. Okay, why we have to use the genetically modification crop, that is crops, because the some of the crops are not able to tolerate the stress. We call it as environmental stress like cold, drought, salt, and heat. There are conditions where in the field the farmer will face us in the day-to-day basis. So to overcome those, that is, it may take a small amount of water. It has to sustain the high salty condition. It has to sustain the drought, cold. Okay, so the genetically modified plant can overcome this abiotic stress. Okay, and also the genetically modified plant can reduce the dependence on the chemical pesticides. That is, instead of using the chemical pesticide, the plant inbuilt having a pesticidal property which can reduce the pest, okay, and increase efficiency of mineral usage by the plant. See, the minerals are present in the plant, sorry, in the soils. These minerals are unable to taken up by the plant because there will be two types. There are micro and there are, hello, ಹೇಳಿ, ಕೇಳಿಸ್ತಿಲ್ಲ. ಓಕೆ, uh, is I'm audible to all? Is I'm audible?
Yes, sir.
Yes, sir.
There was complaint that someone is not audible, so I'm asking once again. Is I'm audible?
Yes, sir.
Yes,
Everyone?
sir.
Then I continue my class?
Yes, sir. Yes, sir.
Okay.
Sir.
You can continue.
Yes, sir.
Okay, I was talking about, okay, increase efficiency. There are micronutrients and the macronutrients. Coming to your micronutrients, where some of the plants will not be able to absorb, will not be able to absorb those micronutrients. So by genetically modifying the plant, the root can absorb those micronutrients. The roots can absorb the micronutrients, and the plant can grow well instead of providing the external minerals. Okay, enhanced nutritional value of food like vitamin A. Okay, and enhanced rice, especially we go for the golden rice, which will be supplied in the African countries to overcome the deficiency of vitamin A. Okay, enhanced herbicides, insects, virus tolerant plant. We can build a virus tolerant plant. A plant supply alternatives to industries in the form of starch, feeds, and pharmaceuticals. That is, plant can and produce those some of the proteins or some of the secondary metabolites which can be used as a pharmaceutical users. Okay. Here in the first example we have a BT cotton. Here BT stands for Bacillus thuringiensis. Here BT stands for Bacillus thuringiensis. It is a soil bacteria. This Bacillus thuringiensis gene, which produces a protein, this protein is a toxic to some of the insects like Lepidotract. The genus, I am saying the name of genus Lepidotract. Okay, that is army worm, and coleoptran, that is beetle, and dipectrans, that is flies and mosquitoes. These, when they feed on the, when they come in contact with the protein, I tell you how, they get killed itself. So Bacillus thuringiensis is toxic. I am saying it is a toxic to the insects of these classes of insects, but not to the animals. That is, and it may be to the animals or it may be to the humans. Okay, what is BT cotton? The Bacillus thuringiensis gene was introduced in the cotton plant. Was introduced in the cotton plant to overcome the effects of insects. Okay, to overcome some of the pesticidal problems. Okay, but not only BT cotton, it was introduced in the BT brinjal and some of the families, but BT brinjal came into heavy criticization by the ethical issues. So we can go through only the BT cotton. Okay, coming to your BT cotton, this Bacillus thuringiensis gene produces a toxin, or we call it as a protein. The protein name, we call it as a cry protein. It's a crystal protein. It's named as cry protein. Okay, there are different types of cry protein. In that, mainly I'll give the example afterwards. These cry proteins are prototoxins. Okay, that is, they will be inactive in the plants and in the Bacillus thuringiensis. In the Bacillus thuringiensis, they will be inactive. So it doesn't produce any effect on the plants or it may be on the humans. It gets only activated. It gets only activated when insects feeds on the leaves and stem of the cotton plant. What happens that these toxin producing genes are introduced into the plant using agrobacterium typlasmids, using agrobacterium tuberficium, using a plasmid name called agrobacterium typlasmid. As I explained, the TI stands for tumor inducing plasmid. Tumor inducing plasmid. What happens when the plant, when the beetle comes and feeds on the BT cotton, it containing a cryoprotein which will be a proactive, it's a protoxin. It get activated in the gut of the insect because it having a alkaline pH in the gut. It gets activated only by the alkaline pH. Okay, once it get activated by the alkaline pH, okay, this pH which binds this cryoprotein goes and binds to the surface of the midgut of the epithelial cell. As the lining of the gut will be normal epithelial, it goes and bind and create a pores that cause the influx of water and ions into the epithelial cells through pores. Okay, that is, it creates a pores on the epithelial cell. Through the epithelial pores, the water get influxed into the gut cell, and the cell lysis takes place. Eventually, the death of the insects takes place. Okay, I told you the cry protein, that cry 2AB, which controls bollworm, cry 1AB, which controls the corn borers, okay. Can I move to the next topic? See, it's very simple. The Bacillus thuringiensis gene, which produces a protoxin, which will be inactive form. It gets activated only in the gut of these insects because of the high alkaline pH. This pH activates the gut, and the activated in the gut. Sorry, this protein gets activated. This protein get activated, and once it get activated, it binds to the epithelial cell, creating the pores and allowing the water inside those epithelial cells, and lysis of the cell and death of the insect. Okay, by this we can control the insects which can feed on the plants. Okay, this was a major success what we see in the bt cotton, and same thing we see the success in the and the BT brinjal also, but some ethical issues which avoided the BT brinjal in the market. Okay, coming to the pest resistant plants. Okay, in the pest resistant plants, here the nematode Miliodigine. Okay, it's a in which it's a nematode which infects the roots of the tobacco plant and causes great reduction in the yield, that means these nematodes infect, not only it infects the plant, it can infect the epithelial cells. So not epithelial, it infects the eukaryotes. It infects the eukaryotic animals. It may be humans, it may be plants, it may be animals. It can infect in the numerous. Okay, okay, coming to the nematodes. See, here one of the complex methods are there, but the textbook has explained very simple form. You just go through the simplified form only. Coming to in the nematodes infection, it infects the tobacco plant. Once the tobacco plant gets infected, it gives reduced in the yield, which makes the loss to the farmer. So to overcome the pest, that is to overcome the infection of the nematodes, here RNA interference are used. Okay. Okay. Here there is a one basic concept here. See, there are numerous, as you know, as we have studied in the molecular basis of inheritance, we have studied about the um replication, we have studied transcription, we have studied translation. Okay, that is replication is synthesis of DNA. Okay, from the DNA we synthesize RNA. From the RNA we produce proteins. See, coming to the nematodes, the nematodes which produces RNA, that is mRNA. This mRNA which produces a protein, this protein which affects the tobacco plant, which reduces the yield. Here, our main main aim is to block the mRNA. See, we can't block the DNA because DNA is a genetic material which is present. We have to block the mRNA. If we block the mRNA, then we can block the proteins. Once we block the mRNA, there is no translation, there is no protein synthesis, it doesn't affect to the tobacco plant. To overcome this, okay, they use a one technique called the RNA interference. Okay, what are RNA interference? See, they are the short double-stranded DNA, which not only we can't say short double-stranded DNA. There are many the RNAs. There are many RNAs in our cell which has a capacity to block the mRNA and synthesize the proteins. Those are the RNAs, we call it as RNA interference. The RNA which goes and interfere in the protein synthesis by binding to the mRNA, we call them as an RNA interference. Here, what happens? In the nucleus, the RNAs are produced. It may be mRNA, tRNA, rRNA, 23S RNA, 5S RNA. Different RNAs are produced. But the cells also produce some of the RNAs. The RNA here, the RNAs which are produced, as we know, the DNA is having a two strands, that is a sense strand and anti-sense strand. It is having a sense strand and the anti-sense strand. Okay, it is having a sense strand and the anti-sense strand. When our this DNA undergo transcription, here the main aim is to the main aim of the transcription is to produce the mRNA on the both the strand, producing the mRNA. These are the mRNA, producing the mRNA both the strand, and making this RNA as double-stranded RNA. Making this RNA as a double-stranded RNAs. Okay, so that the DNA is a replication is a bidirectional, but transcription is a unidirectional, which occurs in the only one strand. There are sometimes the transcription also takes place bidirectional, synthesizing the two strands on that is opposite to the DNA, producing double-stranded RNAs. Okay, now we have double-stranded RNA. Okay, these double-stranded RNAs are broken into a short fragments by endonucleases. These RNAs are broken up by the endonucleases. These fragments are broken by the endonuclease to form a short fragments. Okay, these short fragments are called siRNA. These short fragments RNAs, we call it as a siRNAs, which are 20 which are it's not writing, okay, which are 23 nucleobases to 21 nucleobases. The short fragments of the double-stranded RNAs are broken up by the endonucleases to form that is siRNA, the small interference RNA. Which will be 23 nucleobases or 21 nucleobases. That means now we are having a assume that is we are having two or more siRNAs. Now we are having two or more siRNAs. Okay. Now this siRNAs goes and binds to the a organoids. We call this as an organoid. Okay, a special protein where this RNA goes and binds to the organoids. What is the function of the organoids? Here, organoids will degrade uh, the organoids goes and degrade the one strand. It just degrades the one strand and keeping only one strand, and it's keeping only one strand, so that this organoid is having only single RNA. It's having only single RNA. Okay, now this single RNA goes and binds to the mRNA. This is an mRNA which is ready for protein synthesis. This RNA, mRNA, which will be binded by this, the siRNA, making it as double stranded. Making it as double stranded. By making double stranded, this is the nematode RNA is blocked. This nematode RNA, mRNA is blocked by blocking the protein synthesis, and this can't synthesize the protein. So this is a whole process, this is a complex process. What I explained you is explained in the very easy way method. Here it says only like this, that is the silencing of mRNA due to complementary double-stranded RNA. The molecules binds to and prevent the translation. That is, the mRNA gets silenced by the binding of double-stranded. That means the double-stranded DNA doesn't comes and binds. Here, the complex process which takes place make this double-stranded as a single-stranded, and this single-stranded mRNA goes, this single-stranded RNA goes and binds to the mRNA. Goes and binds to the mRNA. Agrobacterium vectors or nematode specifying genes are introduced into the host. Okay, it is introduced into the host, and both the antisense and RNA strands are present, so that it can produce the complementary double stranded and initiate RNAi, and thus it silence the mRNA. That means we introduce the DNA such that it can produce both the RNAs on the both the DNA strands, and this double strand RNA goes and binds to the mRNA and blocks the RNAi. Now it acts as the RNA and blocks the mRNA, so that the nematode mRNA will not produce any protein and will not affect the tobacco plant. Will not affect the tobacco plant. Coming to the in the field of medicine. Coming to the in the field of medicine. Here in the field of medicine, the insulin production is there. Okay, LA Lilly, an American company, followed the procedure to produce the insulin, and it's called as human insulin with the name called Humulin in the market. Earlier, the production of insulins are obtained through the livers of the pigs. When these pigs are slaughtered, livers are collected. From the livers, the insulins are collected and purified and injected to the human. But there was some complication in that protein, so they have to come across a new method. In the new method was, that is, genetically engineered insulin. Coming to the insulin gene is made up of three segments. In your screen, you can see A strand, B strand, and C strand. What is A strand? That is a green one. B strand is a blue one, and the C strand is a gray one. It is an unwanted thing. The total three strands forms a insulin gene. But the insulin gene, what we needed only the A strand and B strand, which is obtained from the B cell, which is obtained from the B cell of the pancreas, which is obtained from the B cell of the pancreas. How to produce or engineer a insulin artificially? That is, see here, A strands and B strands are held by the double sulfur bonds. Okay, see, only these bonds hold these two A chain and the B chain. We have to obtain A chain separately and B chain separately. Treat this A chain and B chain with the enzyme, that sorry, uh, the the what we call the recombinant endonuclease. Okay, that is restriction endonuclease. We treat this vector as well as the plasmid, what you see here, PBR322, and our gene with the restriction endonuclease, and we join the segment of the DNA in the plasmid, and we introduced into the bacteria cell, and we obtain the A chain and B chain, purify the A chain. I'm not going in detail because the reason is in your textbook there is not so much of detail, so I'm just explaining the procedure. These gene A chain and B chains are taken separately, introduced into the plasmid PBR322, and this is introduced into the bacteria, and the bacteria, they are cultured, and they taken A chain and B chain separately, and they mix the A chain and B chain, and they get an insulin. They get an insulin which can be administered. Understood? Okay, we move on to our next slide called gene therapy. See, from starting to the last, it's very simple. Genetic engineering, taking a gene, cut the gene, insert the faulty gene, replace the faulty gene with the good gene, and introduce into the host and obtain the product. In the gene therapy, it is mainly done in the humans, where especially this gene therapy is done to the for hemophilia, sickle cell anemia, and cystic fibrosis. These are the very deadly diseases which comes by birth. That is from the hereditary. Okay, from generation to generation it is transferred. There is a chance we can block those default gene in the embryonic state and make it healthy, or if we found it the defect gene in the adult also, we can replace and make it correct. Okay, the technique of replacing faulty gene by a normal healthy functional gene, and we call this as an gene therapy. Here the example is, the gene therapy is adenosine deaminase deficiency or severe combined immunodeficiency syndrome. Adenosine deaminase deficiency or severe combined immunodeficiency syndrome. So the first gene therapy was done on the for the 4-year-old girl called name Ashanti in 1990. You can search in the YouTube about the ADA deficiency treatment. You can see a video, but this was an unsuccessful. After 2 months, after a month, the baby got died, and after the 6 months, once again they conducted same experiment where they get succeeded and baby got lived. Okay, but what is adenosine deaminase deficiency? See, there is a fault. The gene, the that is severe combined immunodeficiency we call it, because the adenosine deaminase is an enzyme which is responsible for the functioning of T lymphocytes. If adenosine deaminase is absent, that means in our gene it lacks the functioning T lymphocyte. What is T lymphocyte? I give a just brief note. A T lymphocyte is a immune cell which helps in protecting the infection entering into our body. If we lack the T lymphocytes, then any infection which enters your body will lacks the entire immune system, the entire loss of immune system, which doesn't blocks the infection, and the patient get infected and get dies because of the silly infections. Okay, how we can overcome this? That is, obtain a healthy gene of adenosine deaminase enzymes. Okay, with the help of adenovirus, you take the if they will puncture the bone marrow and get the bone marrow cells. In the bone marrow cells, the cells which produces WBCs and RBCs also produces T lymphocyte. A T lymphocyte is a WBC. Okay, so that it is removed, and those bone marrow cells are injected with the healthy gene. This gene helps in producing the T, that is adenosine deaminase enzymes, and helps in the production of T lymphocytes. Okay, That is a very complex process. It is removed and it is cultured and it is treated, and once again this fluid is inserted into the bone marrow. It's a very painful process. It has to be done every 3 months. It has to be done for every 3 months. Complex and costly process. Okay, severe. So it is called severe combined immunodeficiency. Okay, or a adenosine deaminase deficiency. Okay, to, as I told you, gene therapy, there are two types of gene therapy. Somatic gene therapy, that is which is done, that is replaces the normal, that is the faulty gene with the normal gene in the somatic cells, that is in the cells which doesn't inherit, the cells which doesn't inherit, which will be applicable for the current generation only. If you want to replace the faulty gene and it has to be carried to the next generation, then we have to go for the germline therapy. Germline therapy, where it induces the functional gene into germ cell for correcting the genetic defects in the offspring. The genetic defects in the offspring. Next, coming to the molecular diagnosis. Here, the modern technique of, like, we use the PCR, we use the ELISA, we use the radio immunoassays, okay, for the diagnosis. Coming to the PCR, where we use especially the viruses what we are obtained, it will be in the very low in the number. We need to be amplified. To amplification, we have to use PCR, polymerase chain reaction. I'll not go in detail because in the last chapter I have explained what is polymerase chain reaction. Okay, so with the help of polymerase chain reaction, we can obtain large number of DNAs. From that, we can detect some of the diseases like HIV or AIDS in the patients. Okay, the next one we use autoradiography. Okay, where the strands, the DNA is run on the gel electrophoresis, and those are blotted into the nitrocellulose paper. In the nitrocellulose paper, we combine the single stranded DNA with the radio labeled DNA, and we observe this on the what we call in X-ray. We can observe the ultrasound in the X-ray, or on the what we call the chromogenic film. We can see the bands and we can observe what is the defect in it. And the third one is ELISA, that is enzyme linked immunosorbent assay. Okay, here it is used for detect the where there are some of the antibodies goes and binds to the antigen. By that we can detect some of the diseases which is caused by the virus, bacteria, fungi, mycoplasma, etc. Caused by these diseases. Okay, this is about PCR and this is an ELISA. Coming to the transgenic animals. In the transgenic animals, the animals which carries the foreign gene of interest and produces the product which are needed to us directly. Why we have to go for transgenic animal? Normally we have to study for normal physiology and development. See, I'm teaching you biotechnology, but you can see biotechnology in day-to-day life, especially if you go and switch on your TV. In the news channel, you see a structure called coronavirus. Okay. See, in the coming to the normal physiology and development, here before going for human trial, it has to be studied on the animals to check whether it is having a good effects or bad effects. I'll not go in detail with the clinical trials or something because it's my out of topic. But I want to tell you one thing. Here, how these genes are acted on the a normal healthy person and how the products are delivered. This is very important. I'll tell you example. Earlier days, they want to obtain a anti-venom. They have to inject a small dosage of venom into a horse blood, and they used to run it, give it a small dose of very small dose of venom to the horse. This horse gradually develops the antibodies. This horse gradually develops the antibodies. Okay, these antibodies are obtained once again. The horse, they draw the blood from the horse. They draw the blood from the horse, and then the horse has been developed antibodies. These antibodies are filtered, and these filtered antibodies are injected to the humans. Okay, Here they was used to develop that. Not only that, here we introduce this gene which see the affects how they function in the body. And study of diseases, how these transgenic animals are used to investigate the new treatment in the human disease, like cancers, cystic fibrosis, rheumatic arthritis, and Alzheimer's. Coming to the biological product, as I told you, we introduced the gene and we obtained the product. The examples for first product is the human protein called alpha 1 antitrypsin, which is used for emphysema, where it was been attempt was made also to develop to overcome the phenylketonuria and cystic fibrosis. Okay, where it is human growth hormone which are extracted from the pigs and fishes. That is, the pigs and fishes were delivering alpha 1 antitrypsin. This can be administered to the humans. Okay. Next, come to the especially 1997 first transgenic cow, we call it as Rosie, which produces human alpha lactalbumin. See, lactalbumin is given to the small babies who doesn't have the lactum in the mother. Okay, so these are extracted from the directly extracted from the cow milk, which produces alpha lactalbumin. It can be given to the newborn babies. Okay, next. Also, the similarly human gene for blood clotting factor 8, or sorry, factor 9 has been transferred in the sheep, which can overcome the diseases like hemophilia B, the blood clotting factor. Okay, with the way there will be the person which infected the disease with hemophilia B, where there will be no blood clotting factor. By factor X, introducing the factor X gene, we can overcome the uh, we can overcome the factor X gene, we can overcome the hemophilia. That is, the factor X gene produces the blood clotting proteins. Okay. Next, also it is used for vaccine safety testing. Normally, these vaccines are given to the mouse, and they test for the toxicity, that is especially for kidney, renal failure, or the liver damage, or some other brain damages, or some other side effects which is created by the vaccines, which is now we see in which is taken place in our coronavirus. You can see in the newspapers or in the news. Okay, and also the chemical safety testing. Okay, transgenic was made to carry the gene which make them more sensitive to the toxic substance, and non-transgenic animals which are exposed to the toxic get affected. We can be studied in that. Okay, especially it is done in the pharmaceutical industries. Next comes to the ethical issues. Okay, next comes to the ethical issues, biopatent and biopiracy. The genetical modifier, where it's coming to the ethical issues, as I told you, there was some of the ethical issue in the BT cotton. Yes, what happened once the BT cotton was successful? Now we can't see there is no BT cotton in the market because gradually it is reduced its yield. Okay, there was a heavy boom at around 6-7 years. That is the BT brinjal. The BT brinjal was giving the highest yield, having a very good, because why we go for BT brinjal, if you see the brinjal, or we call it as badnekai, you can see the insect which attacks the brinjal more. The the insect attacked brinjals, having the less, that is the people will take it less rather than when need brinjal. So the genetically modified, that is BT brinjal, where insect doesn't go and hit those brinjals, so the brinjal will be very nice and clean and with a good weight, and it can be have a good value. But there is one ethical issue, that is it thought that the gene of some other animals are introduced into the plant, so the people has to eat those genes of other animals, like eating a brinjal and thinking like it is a chicken. This was an problem with the some of the issues, and the same we can see the issues in the insulin also, because the insulin also was obtained from the pig in the earlier days, so that once it man is inserted into the human, there are some communities which they hate the pig. There are some communities that don't take the non-vegas. They got affected by those. But the gene, we have to ask ourselves, the gene what we have obtained or we have copied, it has to be copied from some of the organisms. Okay. Next, these ethical issues were created are the major issues in the genetic engineering. Okay, there are so many pros and cons, and also you can there are so many things in this chapter which is not included. By the genetical modification, there are both positive and negative. That is, we will get a desired product also, and also we get an undesired product. The best example was corona. It is used to treat. There was a saying that it was a experiment which is conducting on the SARS virus. It is taken from the bat, and they want to develop a virus so that which can kill the SARS, but it is now infecting all over the world and killing the people. So I told you there are both positive and negative in this aspect, where we can get good aspect also and can get a bad aspect also. Okay. See, I want to tell you one thing. If you have seen the movies of zombies, okay, the zombies comes in bites, the bitten people becomes a zombie. It's the same case what we are seeing. Infected person comes and touches us and we get infected. Okay, now nothing but a world has become a zombie land. Okay, now this is about the ethical issues. Okay, so to overcome, there are genetically engineered approval committees in the Indian government which approves these genetically modified plants and organisms. It gives approval seeing all these issues. Okay, and the researcher. Next comes the patent. A patent is essentially a contract between the society as a whole and an investor. Nothing but if you have a product, you think it's an unique, so that you don't want to make it, that is, so no one has to copy your product, so you will do a patent, that is a right on a product, so that no one has to copy. If they copy it, they violate the patent act and they have to pay the amount what you have. Okay, that is a patent issue. Coming to a patent, a set of exclusive rights granted by the government to an investor or an application for a certain period of time. That is, it's not for a lifetime. What the invention, what you've done, it is only for a particular period of time, such that you can produce and you can release in the market, but others can't manufacture it, others can't release it. Okay, you will be only the sole person to release for certain period, like 17 to 20 years, and prevent others from making, selling, and importing the given inventions. Okay, so that the America is very busy with buying the inventions from the other countries, those are having a vaccine against the corona. Okay, coming to why we have to go for patent act. See, we have around 27 varieties of basmatis in India, 2 lakh varieties of rices in India. The some company, American company in 1997, it invented some aromatic properties of the basmatis and some of the medical properties of basmati, and they just used a US trademark patent and the trademark, and it put a ban on selling of basmati in India, growing and selling basmati in India. It put a total restriction of selling and the basmati in India. Okay, but this restriction was overtaken by the Indian government, giving the some of the proofs that it is our ancient method. We are growing from several years. Okay, and there are also made for several attempts for turmeric and neem also, so that they have invented some of the antibiotic property in turmeric and the neem, so that no other should use those property rights. But it's an ancient Ayurvedic medicine. It also the Indian government has overcame those patent rights. Okay, coming to the biopiracy, it refers to the use of bioresources by multinational companies and other organizations which would proper authorized from the countries and people concerned without the compensatory payment. That means the product what you are having, the innovation what you are having, it is copied and released into the market. We call it as a biopiracy. Okay, the Indian government, which has clearly cleared the second amendment of Indian patents bill, which takes such issues into consideration, including patent terms, emergency provisions, and resources. There are some examples. in especially in the Kerala. Jamun and Began are used to control diabetes. It is used to control the diabetes in common treatment in India. But the foreign-based firm, hello, ಹೇಳಿ, ಹಾಂ, ಬನ್ನಿ ಒಂದು 10 ನಿಮಿಷ ಬನ್ನಿ, ಸರಿ ಬನ್ನಿ, ಬನ್ನಿ, ಅಂಗಡಿ ಹತ್ರ ಬನ್ನಿ. Okay, Indian government has successfully in cancelling the patent guarantee by the US Patent Office on handling the properties of turmeric also. These are some example I have given. And this finishes this chapter. This finishes your this chapter. Okay.